I'm back. Mwalimu Arnold Sekaga as usual, trying to dissect some key components of A-level chemistry. Then for 3 electronic groups, colleagues, don't forget what an electronic group is. If you are watching this for the first time in the previous video, I have defined what an electronic group is. Now, if you are having 3 electronic groups surrounding, surrounding an atom, the geometry, by the geometry and shape, those things are different. Geometry, you are looking at 3D structure, but shape, you are looking at how those atoms are situated. Geometry, 3 dimension, but shape how the atoms are situated. Now, for 3 electronic groups, valence shell electron pair repulsion theorem says that the geometry is trigonal planar and the angle is 120 degrees. However, we are going to see that for this, I think it is, for the 3 electronic groups, for 3 electronic groups, there are various possibilities. Now, like, okay, let us start with this one, which is very easy. Boron trifluoride. Now, boron trifluoride, do you know how it looks like? Boron trifluoride is boron with 3 bonds that are bonded. You see, boron carrying 3 fluorines. Those are 3 groups, 3 single bonds surrounding boron, 3 single bonds surrounding boron, making a total of 3 electronic groups. So we call that type of geometry trigonal planar, and the angle is 120. Now, these others, they are a bit technical because some of you now forgot alkenes, what alkenes are. Now, this is methanol. Some of you don't know methanol. So kindly take note of them, but we shall dissect them. Because now, I don't know whether it is going to make sense. This is ethene. In O level, you were taught ethene. Ethene is made up of, this is how ethene looks like. If you try to open it like that. Ethene, I think you were taught ethene. Ethene is not new. This is how it looks like. So look at the carbon atoms. We have this carbon atom here and that carbon atom here. This all those two, both of them, they are surrounded by 1 electronic group. You see, this carbon is having a single bond here, a single bond here, and a double bond here. All those are 1 electronic group, so making a total of 3 electronic groups surrounding this carbon. Same thing applies to this. So that type of geometry is the trigonal planar. Then this is methanol. You people don't know methanol. Maybe those in senior 6, they know what it is. Then the next one is the 4 electronic groups. 4 electronic groups where you have 4 things surrounding an atom. 4 things. Now methane. Still, we drew the structure of methane in class. This one, we looked at that example. Also for this is hydronium. I explained this coordinate bond within hydronium. Now, it says that valence shell electron pair repulsion theorem is the one I'm referring to. Valence shell electron pair repulsion theorem says that if you're having 4 electronic groups, the geometry is tetrahedral. The geometry is tetrahedral and the bond angle is this. Now, you may ask me, teacher, now, how do those bond angles come about? Now, these bond angles, they are standard angles. If we say that you are linear, that is 180. Trigonal planar, the one before, trigonal planar, that is 120. Now, for tetrahedral, it is 109.5 degrees. These are standard values that have been investigated and identified using machines like using concepts like nuclear magnetic resonance, mass spectrometers, infrared spectroscopy, which other one? X-ray diffraction machines. They are standard values. Yeah, they are standard values. I want you to also take note of the fact that for tetrahedral, it's a bit chaotic. Why? I don't know why this thing is failing to move. If there are 4 electron groups, there is something which I've been mentioning, that geometry is different from shape. If there are 4 electron groups, the geometry is tetrahedral. However, 4 electron groups, remember, an electron group is a single bond, double bond, triple bond, or single electrons. There are 4. These are also 4 electron groups. You see this one here. In ammonia, these are 4 electron groups. You see this line here, this is 1 electron group. This is another electron group. This is another electron group. Then this lone pair is also another group. There are 4. You see, don't look at the bonds only. We can also have a case where electrons are there. And previously, I have defined what an electron group is. A single bond, double bond, triple bond, or electrons. Now, these are 4 groups. There are 4 groups, so the geometry here, the geometry is tetrahedral, but shape, I think it is also highlighted here. Can you take note of it? The geometry, if 3 electron groups are bonding groups, like for ammonia, if 3 electron groups are bonding groups, and 1 is a lone pair, the angle is approximately 107. Now you see it changes slightly from the 109.5. Now, to create a clear distinction, look at this. These are 4 electron groups, but we don't have a lone pair. There are 4 electron groups, but we don't have a lone pair. Then down for ammonia, there are still 4. You have 3 bonds plus a lone pair. Still, there are 4 groups. There are 4 groups, meaning that the geometry is still the same, but the shape is going to change. Now, there is no way you will say that. There is no way you will call this. There's no way you are going to say that the shape of this methane is similar to that of ammonia. No, they are different. They also have different atoms. Okay, as in terms of their number. Within methane, you have 4 hydrogens. Within ammonia, not ammonia. Within ammonia, you have 3 hydrogens. But what the similarity, where the similarity is, in both cases, what do we have? We have 4 electron groups. Here for methane, all of them, they are lines. For ammonia, 3 are lines, 1 is a lone pair. The geometry is also the same, tetrahedral, but the shape differs. Now for ammonia, you see how we call that shape? Trigonal pyramidal. Trigonal pyramidal. It is here down. Trigonal pyramidal. Then here, I think I have explored all the electron groups. Maybe I need to summarize them in a table. Kindly, maybe I stop sharing